Hey guys, this is AP Calculus notes for FTC Part 1 and function values. Okay, so first, remember FTC Part 1. FTC Part 1 says if you have, or if capital F of x is any antiderivative of little f of x, then the integral from a to b of little f of x dx is capital F of b minus capital F of a, right? It's just a recipe of how to take a definite integral, okay? Well, we could write this a different way. I could write it like this. I could say the integral from a to b of f prime of x equals f of b minus f of a, right? It's really saying the same thing because an antiderivative of f prime is f, right? Up here, an antiderivative of little f is big F. So it's really saying the same thing, just in a little bit slightly different language, right? So the integral of a derivative is the value of the function at b minus the value of the function at a. Well, this can be rewritten. This can be rewritten like f of b equals f of a plus the integral from a to b f prime of x dx, right? That's the same thing. All I did is I just went to this equation, this original thing here, and I just added f of a to this side, and I added f of a to this side, right? That's all I did to get this expression. But this is really useful because if you think about what this is saying to get the value of a function at any point, you just take the value of the function at another point, any other point, and you add this antiderivative or this definite integral to it, okay? So one way of interpreting this is you could say that this integral part of it is like the total accumulation of change. That's what this is. This is really how much change occurred in f of x between a and b. This is the total accumulation of change in f of x over the interval from a to b. Right? That's really what that definite integral represents. Okay? So how can this be used? Like sometimes they might give you a derivative, right? Like for example, they might say something like, suppose we know that f prime of x is equal to 8x squared plus 7. Something. I'm just making this up. And suppose we know that f of 1 equals 3. Let's say that's the given stuff. They might say something like find f of 5 or something like that. All right. So all you'd have to do is you could just say f of 5 is really equal to f of anything else, including f of 1, plus the integral from 1 to 5 f prime of x dx. Right? This is really just FTC Part 1 written a different way. And we know all the different pieces of this. This is just going to be 3, f of 1, plus the integral of f prime from 1 to 5 of 8x squared plus 7 dx. And now I could just do this definite integral either using my calculator or by hand or whatever. This one's easy to do by hand. This would be 3 plus 8x cubed over 3 plus 7x evaluated from 1 to 5. So this would be 3 plus 8 times 5 cubed over 3 plus 7 times 5 minus 8 times 1 cubed over 3 plus 7 times 1. Boom, done. That's f of 5, whatever that number happens to be. Okay. Sometimes you can have applied problems that are involving this FTC Part 1 as well. Like, for example, suppose they said that water's being pumped into a tank. Okay, so suppose water is pumped into a tank at a rate of R of t equals the square root of t plus 1 gallons per minute. Okay, if there's 100 gallons of water in the tank initially, how much water is there after 3 minutes? Okay, well, this is the same type of problem, right? If you look at this word rate, right, that means derivative. This is the derivative of the amount of water in the tank. That's what this is. It's the derivative of the amount of water in the tank. Right? That's what rate means. And then it says if there's 100 gallons of water in the tank initially, well, that means at t equals 0. How much water is there when t equals 3? That's what they're asking us to find. So let's just say let a of t equal the amount of water at like t minutes, measured in gallons, of course. We're trying to find a of 3. But a of 3 is just equal to a of 0 plus the integral from 0 to 3 of a prime, which would be r of t. That's all there is to it. So this is just going to be 100 plus the integral from 0 to 3 of the square root of t plus 1. Square root of t plus 1. Remember, this is that shortcut u substitution thing. It's going to be t plus 1 to the 3 halves times 2/3. This is 100 plus 2/3 of 4 to the 3 halves minus 2/3 of 1 to the 3 halves. So 4 to the 3 halves, that's the square root of 4 cubed, which is 8. So this would be 100 plus 16/3 minus 2/3. 100 plus 14/3. Whatever that is, gallons. That would be the answer. Okay. There's another type of, a really common type of application of this type of problem is like a velocity problem. Okay. Suppose they tell you that a car is traveling at a velocity of v of t equals t squared plus 6t plus 12 miles per hour. Okay. If the car starts, let's say 53 miles from home, how far from home is the car after 5 hours? Same type of problem, right? When they're giving us velocity, they're really giving us the rate of change of position, right? This is like s prime of t, right? That's s prime of t, the rate at which the position or the distance from home is changing, right? If the car starts 53 miles from home, that means that v of 0 equals 50, sorry, s of 0 equals 53. We're trying to find s of 5. So s of 5 would equal s of 0 plus the integral from 0 to 5 of v of t. They're giving us v of t. You plug the stuff in, you do the integration. That's all there is to it. Okay. One last type of problem that you'll likely see is like a graphical type problem. So suppose they gave us a piecewise graph. Okay, so suppose they gave us something like this. I'm just trying to draw a simple piecewise graph that we can actually calculate areas for. So suppose we have this piecewise graph and the function is just linear piecewise. So it goes like that, and then let's say it goes like that, goes maybe down like that. I'm trying to make it really good here, and then let's say it goes like that. So there's the function. Okay, and suppose this is actually f prime of x. F prime of x. Okay, they might say something like if f of -2 equals 3, find f of 4. Well, it's really the exact same type of problem. You're just going to say f of 4 is f of -2 plus the integral from -2 to 4, f prime of x. So f of -2 they're giving us outright. The integral from -2 to 4 of f prime, this is like yesterday's problems where you can think of this as like a signed area. Okay, so again, looking at this graph, there's a lot of stuff that cancels. Like we have a positive area right here. That's going to cancel with this positive area right or negative area right here because they're equal sized triangles, right? Same thing goes for this triangle right here and this triangle right here. They're equal sized triangles. One's positive, one's negative. So all you have to really count is that right there, 2. The total integral here is going to be 2. The answer is 5. Okay? So that's the bottom line. The bottom line is the definite integral of the rate of change of any quantity is the total amount of change of that quantity. That's the bottom line. Okay, the definite integral of the rate of change of any quantity is the total amount of change of that quantity. Okay? One more thing, there's 2 handouts that deal with this that are on Google Classroom. One of them was going to be assigned today, and one of them was going to be assigned on Friday. Okay? So the first one is called FTC and function values. And for this handout, don't do number 3. Don't do number 3. You won't be able to do it because it involves a topic that we're not going to talk about until next week. This is an old handout that I made up, and I used to do things in a little bit different order. So don't do number 3. It involves something called Riemann sums, which we haven't really talked about what that is yet. Okay? But we'll come back to it. You'll be able to do it eventually. Okay? And then the second handout is just called More FTC. More FTC. Okay? So I had assigned that originally for Friday because Friday I'm not going to be giving a lesson or on new material or anything like that. I'm taking a personal day. So I also won't be available for office hours on Friday. Okay? So for today and Friday, you have 2 handouts, FTC and function values and More FTC. That's all I got for today. Make sure you smash that like button. Thanks. Have a great day.